So let's talk about vectors. So what is the basic understanding that we have to understand about vectors? Okay, first, the thing that we have to remember when we talk about vectors is actually very simple. Vector, when we say vector, that is a directed line segment. Okay, so we know a line segment. How does a line segment look like? A line segment looks like a line with an arrow. Okay, so just like this one. This one, that's called a line segment. Okay, this is called a line segment. And most of the time, we're going to be looking at this line segment, and we are actually looking at letters under them. They are called vectors. Okay, so the first thing that you have to remember is that a vector is just a directed line segment, nothing more, nothing less. Now, the word magnitude is really a very fancy word to tell something about this, because magnitude is just simply the length of the vector. Okay, so imagine that when you're going to have a line segment, you have here your tail. Okay, here's the tail, and you have the head. The head has the arrow. So the tail is the very first, and then you have the head. Now, from, let's say the tail starts from A and the head ends at B, then that's going to be called a vector AB. Okay, so we write vector AB as A and B, and then an arrow like that. Now, the word magnitude is that it's just telling you what is the distance from A to B. That's called distance. Okay, in our lower mathematics, we call it distance, but in this lesson, we call it magnitude. Okay, so that's the very basic thing that we have to understand about these vectors. Nothing more, nothing less. Okay, so let's look at vector vocabs. So first, let's look at 1 point. Okay, let's call that 1 point point A. Okay, here we go. I'm going to draw 1 point A. This is called point A, and then I'm going to put here some, let's say, another point here that is called point B. Okay, so the first thing that I would like you to remember again is that a vector is just a directed line segment. Okay, this is a line segment. Okay, and I'm going to put an arrow in there. That makes it a line segment. Okay, let me write that one. A vector is just simply a directed line segment, like our example here today. Okay, now what are we going to learn here? First, the vocab is the initial point. So from starting point A, this is what you call your initial point. Okay, initial point, and the B now will serve as your terminal point. Okay, so these are very familiar terms when you were studying trigonometry. Okay, sometimes you can also see some vectors like this. Okay, let's start from C, and it's going to go this way, and then this point, it step on this point, and that's going to be point D. However, in between C and D, there are what you call arrows also. This is also called vectors. Okay, they are still called vectors. Okay, what else are we supposed to study here? So the notation that we're going to be always using is we're going to put the starting, or we call it the initial point, and the terminal point, and we're going to put a line in that. That's called the notation. It is also called this notation. If you're going to look at this notation, this is also called the vector displacement notation. Okay, displacement notation. This is very important to understand. So let's look at this example. So let's say that a vector has a fixed point, like the point of origin here. This is our point of origin, 0, 0. And if from point of origin you have this 5 units from 0 and 9 units from 0 on the y-axis. Okay, so we can represent this vector this way. Okay, it's going to be this is going to be your x on the top, which is going to be 5, and then below is going to be 9. Okay, now there are many more representations. Okay, example, let's get another one example. Okay, so for example, our vector is starting from here, let's say from this point, and then it's gonna go this way. Okay, so let's count from here. 0 0, we can, how do we represent this one? That's the arrow. Okay, so here 0 1 2 3 4, that's gonna be on the 4. Here on the x is going to be 1 2 3 4 and 5. This is 5. So we can represent this in this type of notation or representation. We call it that's gonna be 5, and then it's going to be how many down from here? 1 2 3. It's gonna be -3. Okay, why -3? Because it's going down. Okay, so if you're going to be looking at this first example here, if you're going to be looking at that, why it's 9? Because it's going up from 0. In this case, you are going down the y-axis, so it's going to be negative value. Okay, that's the very basic understanding in here. Okay, so let's see some more examples. So say for example, let's now going to reverse. Okay, you are going to be given let's say a vector u is equal to, let's say this has 0 and 2. Okay, now from this vector, let's get a point from here. Okay, that's going to be there. So if you're going to say 0 and 2, how are we going to do that? 0, that's going to be 2. So the point, this is what you call your initial point. Okay, remember, this is your initial point. This is the starting point. The initial point, that's gonna be your 0. Okay, that's gonna be your 0, and you're going to put it up 1 and 2, and that's gonna be your vector. That's gonna be the vector. Okay, I hope you understand. Let's try it again. Okay, example, I'm going to, let's say I would like you to make a vector w as say 3 -1. Okay, so let's see, let's start. You can use any dot in here. Let's say I'm going to use this 1 dot in here. That's my 0. Okay, so if we're going to say 3, where can you find 3? It's gonna be on 3 on the left and then 1 down. Okay, so from here 1 2 and 3, that's gonna be my 3 on the x-axis, and then I will go down one more. So from here, from the initial, I will be ending on this part. So this one is going to be your 3 -1. Remember, I went down 1. Okay, so that's why it's negative. Okay, I hope you understand these some simple examples. Quick instructions on negative of a vector. So let's say, for example, you have point A, okay, going to a certain point, we call it point B. Okay, there can also be, let's say this is going to be what you call a vector AB. Yeah, now what about if it's going to be, let's say we're going to make it as a negative. Okay, so when you're going to be doing a negative, it's going to be going back. So just like this one, if you're going to be looking at this one, AB, okay, we can also put that as negative vector, the negative of that vector, negative AB. So, but how are we going to write that one? If you're going to be doing it, it's going to be from, you're going to be still from point A, and then here's going to be your point B, but now the direction of the arrows is going to be going back. Okay, whoop, goes this way. Okay, that's going to be the negative of a vector. Okay, very simple, nothing more, nothing less, but I would like you to really understand it, that there's going to be also the opposite side of a vector. Write the vector represented on the plane as a column vector. Okay, first step is we're going to look at the initial side, and you have the terminal side. So we're just going to be looking at how many steps. Okay, so from here 1 2 3 and 4. So this is going to be 4, and then from there again 0 1 2 3 and 4. So this is going to be 4. Now if we're going to be writing the column vector, there's going to be 4 going this way and then 4 going that way. So that's going to be 4 4. Okay, simple as that. Okay, so let's look at the blue line this time. Okay, let's focus on the blue line. Now in here, we're going to start again from the initial. This is your initial. Okay, so from the initial going to our terminal side. Okay, so let's see if we're going to be counting from going there. How many units will that be? 1, 2, 3, and 4. But now from here, I'm going down, so it's going to be 0, 1, 2, 3, 4. That's going to give you a negative 4. So if we are going to write again the column scalar for this, it's going to be what? It's going to be 4, negative 4. Okay? That negative 4 down is going to be on the y, and that's going to be on the negative. Okay, I hope you understand this very well. Okay, so let's look at this one. Plot the vector 5, 9. Use the origin as the starting point. Okay, use the origin. It means that we're going to start from here. Okay, 5, 9. It says 9, 5. So say 1, 2, 3, 4, and 5. And then 9. It goes up to 9 here. My 9 is up here. So from initial, you're just going to connect it, and that's gonna be your vector. Okay, so as simple as that. Okay, let's do it one more example. I'm gonna give you, let's say example 7 and then 2. Let's give you another example, let's say 4 and let's say 3, and then another vector, let's say 10 and let's say 10, 10. Let's do it 10, 10. Okay, 7, 2. Let's go for this. Okay, let's use another color for 7, 2. This one, so say 7 from 0, 7, and then it goes up 2. So from the starting point, it's gonna be going this way. So that's going to be your 7, 2. Okay, let's go for this next one. Let's try this one. 4 and 3. It says 4, so 4 from the 0, 4, and then it goes up 3. Okay, so that vector is going to be there. Okay, last but not the least, okay, 10, 10. Okay, from there 10, then up the 10. My 10 is somewhere here, so that's going to be my 10, 10. Okay, so this is how easy it is. I hope you understand this very well. Okay, so let's look at the component form of vectors. What is this all about? We're not actually running away from it. So earlier in this video, we took 2 points, yeah, starting A and then B. Okay, the initial going to the terminal, and we call it vector AB, right? Okay. Now, the component form is going to standardize everything because there is a special letters that's going to be connected with your x and y axis in your coordinate plane. Okay, so just like this one, in your coordinate plane, you have your x and your y, right? So if you're going to be using this a and b, vector a, b in here, this a represents like your x and this one represents your y. However, for the component form, we are not going to be using AB all the time. There are actually 2 vectors called I and J. So here, when you say vector I and J, okay, so we're going to be associating I with the X, okay, and J with the Y. Okay, let me just write that in some different color. So our I is connected with X and J is connected with Y. Okay, as simple as that. Okay, let me give you an example. Okay, so say for example, in the coordinate pair, okay, we're going to say 4, 3. Okay, now we're going to represent this as 4i plus 3j. Okay, now look at this one. This is your x and y, right? But that x represents I and that y represents j. Okay, so whatever the sign in here is going to be the same thing. Okay, so let's plot this one. Let's say 4, 3. So 4 units on the I axis or x axis. 1, 2, 3, and 4. this is going to be your 4, and then 3 units on the J1, 2, and 3. Okay, so this is going to be your 3. If you're going to be, let me just put that in. If you're going to be starting from this point of origin and going to its terminal, this terminal is going to be what you call your 4i plus 3j. Now, it's just simply saying, like in your lower mathematics, if you're going to be having this or converting it as a point. Okay, let me just put that example. This is just a point. Yeah, that point is actually what you call 4, 3, because it's just your x and y, right? But this time, since you are talking about vectors already, there are now what you call your component of vectors, which is using I and j respectively. Okay, let's give more examples. Okay, examples only, okay, for you to understand it carefully. Okay, let's draw a little graph in here. So let's say, there you go. Okay, let's plot at least 2. Okay, what are the things? Let's say we're going to plot, or sorry, not plot, represent. We're going to represent, let's say 3, 4 in a vector way using I and j. Okay, so that in terms of I and j. So we're going to be rewriting that as 3i plus 4j. Okay, remember your x-axis is here and I is always related with it. Your y is here and it's always related to your j. Now, point of origin, 3 units, 1, 2, and 3. Okay, that's my 3 units in there. 4 units in there, 1, 2, 3, and 4. So if I'm going to put now my vector for that, it's gonna be looking this way. The meeting point is somewhere here, so it's gonna be like this. Okay, now let me label this one. This is now going to be your 3i plus 4j. Okay, I hope you understand it very well. Let's put one more. What if from the point of origin this time we are going now to plot something in here? Okay, example, we're going to plot different color this time. Let's say 6 negative, let's say negative 6. Okay, example like that. So in terms of I and j, you're going to say 6i, since this is minus, say minus 6j. Okay, this is going to be what you're going to be plotting. So from the point of origin, 6 is going to be from here, 1, 2, 3, 4, 5, and 6. That's going to be your 6. And then 6 down. Okay, negative. So 1, 2, 3, 4, 5, and 6. That's going to be your negative 6. So the meeting point of this is going to be like that. Okay, so your vector initially will start there and its endpoints will there. Okay, so this is now your initial, and now if you're going to label this one now, this vector is called 6i minus 6j. Okay, as simple as that. I hope you understand this one. Okay, so let's look at the magnitude of a vector. Earlier in this video, we said that vector is a line, is a directed line segment. This one, okay, it's a directed line segment. Now we're going to look at this time the magnitude. Okay, this is one of the components, or the characteristics why a vector is very special. It is a directed line segment, plus it has the length, let's say length or size. Okay, some other says there's going to be a size of that. This is really size. So magnitude, when we talk about the magnitude of the vector, it's going to be talking about the size or the length. Okay, the length of a vector. Okay, so earlier in this video you talk about the vectors. Okay, from this one AB. Now we're going to write the magnitude like an absolute value, like A and B, like that. less than absolute value. But that is not an absolute value, okay? That is the symbol of what you call magnitude of a vector. Okay, so how do we find the magnitude of a vector? So basically, it has a formula, okay? It's like AB, the magnitude is going to be equal to the square root of 2 points, okay? x2 minus x1 square plus your y2 minus y1 square, okay? So if you're going to be looking at that, it's really very familiar because it's like the distance formula in your lower years. But this time we're going to be doing the same thing. So what does this mean? It means that there's going to be an x and then y, and then another one is another x and y. But this is going to be, the first one is x1 and y1, the other one is x2 and y2. Why do we need that? Because remember, that vector has a magnitude, and the magnitude is going to talk about the length, the size, or earlier I said the distance in your lower year. Okay, but in this case, we don't call it as a distance, we call it as a magnitude. So magnitude is somewhat the length. Okay, so say for example, we're going to give you an example in here. Okay, so say for example, let's say A is located at 1, 2, and then let's say B is located at 4 and 6. Okay, and let's look at that part. Let's graph it first. Remember, that's graphing is cool. So here, this is going to be 1, 2, 3, 4. And then let's say 1, 2 is here, 1 and 2 is somewhere here. Okay, and then 4, 6. 1, 2, 3, 4, and then 6. 1, 2, 3, 4, sorry. 5 and 6. This is your 6. Okay. This is your 4. And it's gonna be there. Okay, so that's going to be from initial to the terminal. Okay. So what does this mean? It means to say that if you're going to look at it very carefully, what happens now here is that to go to, this is our A, this is our B. To go to B, you have to travel here, 1, 2, and 3. Yeah, this is 3. All right, and then 4 going up. Okay. So with that said, right now, we're now going to represent this to our vector with this one. Okay, using I and J. Okay, I hope you still remember that. That's going to be, our vectors now is going to be 3i plus 4j. Okay, that is our vector. Now, remember that the magnitude is going to be this one. This is going to be the magnitude. This part, what is the distance of this? Okay, you are being asked to find the magnitude of this. So let's see. Magnitude is, as I said earlier, we're going to be using this one. Okay, but once you are going to have these vectors in its proper component, okay, proper component is I plus j, then it's going to be very easy now. Because the magnitude in here, okay, the magnitude of this, okay, it's like this one, it's going to be the square root, something like this. If you're going to be looking at it, something like this. Okay, something this. However, I'm going to simplify my x2 and x1 and y1, y2. Okay, it looks this way. We're going to use now this 3 and this 4. So it's going to give you 3 square plus 4 square. Okay, is equal to give you 9 plus 16. And 9 plus 16 is 25. Therefore, the magnitude of that is going to give you 5. So the distance, if we're going to be looking at this one, is 5. Okay, that's the distance in here. That is the distance in here. Okay, you might be very confused. How come that I use these numbers in here instead of showing me how to do this? Okay, so let's do this one. Okay, using these points right now, we're going to use our formula that I just gave you there. Okay, so let's do that together. Okay, so our points are going to be located at, our A is 1, 2, and our B is 4, 6. And we are asked to find the magnitude of AB as our vector in here. Okay, let's rewrite our magnitude in here, our vector in here, AB. Okay, our AB. I'm using AB because I haven't represented these 2 points yet in its component form, okay? Just like this component form, that's what I'm saying. Okay, so in here, it's going to give you the square root of x2 minus x1 square plus y2 minus y1 square. Okay, so let's see the distance. Anyway, we're just actually looking at the length. Okay, let's label that x1, y1, and this is going to be x2, y2. Okay, with that said, we can now proceed. Okay, so there you go. My x2 is going to be 4 minus 1 square plus my y2 is 6 minus 2 square. That's gonna simplify to 4 minus 1 is 3 square plus 4 square. So now if you're going to be looking at this part, this one is now identical to that. See? Okay, so it's now going to be the same. This is now going to be 9 plus 16. Okay, and 9 plus 16 is 25, and that's going to give you 5. Therefore, the magnitude of vector AB is equal to 5. So that actually is going to prove our point when we graph it here. Look at this graph. Okay, so we have 5 in here, so it's going to be correct. Okay, so I hope you understand about magnitude. So far so good. These are the basics of your vector. I hope you understand everything. Have fun.